instances, now they are practicing additive, and for us, the goal is to create whatever we can imagine.
And with a number of different kinds of materials, many different kinds of metal?
Right, right. Yes, sir, go here and that comes. Yes,
So, can you talk a bit about the regulatory approval part of additive manufacturing and, you know, kind of what your approach to that is,
Yes.
and how the regulatory agencies are embracing, if you will,
So
or not?
we actually invited FAA to come visit with us last year, and they came and saw, and the way we demonstrate the equivalency is based on the material curve. So whether you have traditionally, one of the first things we do is we do test bars. We print a test bar and test it, and we show that the test bar we just printed is as good as we did before. And the FAA came and spent a day with us, and they were very complimentary. We have certified on LEAP that is flying now, and it has several thousand hours of experience on it. We do have the fuel nozzle as a printed part. We also have on GE90, we have a T25 sensor as a printed part. And then we have several others, both in commercial and military in development cycle, including the ATP that I just talked about.
Okay, great.
Yes, sir.
Well, two questions. Are there any rotating components in this engine that will be made from additive printing?
Not yet.
Not yet?
Not yet, not yet, not.
And does this come from the
But
motors?
wait.
Okay. Wait, in ATP?
No.
Oh, okay. Does this technology that you're using for this engine come from the Morris part of GE or Fiat?
No, so Morris was a supplier to us that we bought.
Yeah.
Buying that enabled us to take a closer look. But Aviation also uses a technology that prints part as well, which is part of but they use a different technology. They use electron beam. This is a laser. But the end result is similar, because depending on what application you have, you use different modalities.
So will the factory be in Europe or?
Those are decisions to be made.
Okay.
Yes, sir.
Actually, I would have 1,000 questions, but let's limit to 3. So, basically, which material are you using? As far as I know, titanium is suitable for that very well. Aluminum a little bit less. So, which materials are you using, and how about the use of composite parts?
So
Printing.
yeah. So we on these products that we're talking about, we use aluminum, titanium, Inconel, cobalt chrome, and few others that without giving you a list of a lot of things, but those are the materials that we.
What about superficial roughness? How do you cope with the roughness of material, because printing is not so smooth as
So you will have a post-processing just like you would with regular. Yeah. Well, once you produce it, then you have a post-processing, whether you do shot peening or do polishing or you do slurry, whatever, if you need that smooth surface. On the outside part of it, sometimes you don't need any smoothness. Yes.
Two questions. One is, are these roughly the largest sort of components that you'd expect to produce for, say, an ATP?
For today, yes.
For today?
Yes.
Okay. So the bigger the oven, the bigger the part you're
Right.
putting into the
Right.
And then secondly, really, is you said that you sort of interrupted the ATP design process a little bit after it had begun. So do you think you could go back into that cycle with an upgrade for the engine?
For the next generations, definitely. For the next generations, definitely. The numbers that they put on the chart here was when we saw it going, and I called Brad. I said, "Guess what I have for you?" And we had a dialogue. But if we're given a clean sheet of paper, because on ATP we had a commitment to a certain date to fire the engine, to fly it, and so on and so forth. We didn't want to disrupt that, but we cut the back end of it. But if you give me a new engine, for example, today on some of our other applications on our military side, we're starting from clean sheet of paper. The benefits are a lot more. Yes, sir.
Along with Brad and I have had this conversation a couple times, but when the regulators first came to us a couple years ago and said, help us figure out how to regulate additive manufacturing, one of the things they were very concerned about was difference in forging and casting and the crystalline structures and how they line up.
Right.
So in your experience with using the lasers, you know, are there trade-offs there, or is it dependent upon the metal, and is there a difference? Can you ever get more strength out of additive than you could out of a traditional process? And then the second question for Brad is, are there fingerprints on that can tell that you produced that and not some counterfeit part manufacturer, you know, as we go forward and this starts to proliferate throughout the industry?
So the first question is easier to answer than the second one. The first one, we understand the properties of casting, forging, and so on and so forth. We also understand, have a good feel for properties as we print this. We can orient it in a certain way, we can program it in a certain way to get the strength the way we want to get it. And actually it helps the design mind to open up. More work needs to be done as we get more and more to sophisticated materials. The second part that to say, these parts that they are serialized, definitely there is enough fingerprint on it that you know exactly what has happened. Whether the future somebody can do counterfeit or not, I haven't thought through that yet.
Let me just clarify one thing, when Mohammed is being very humble here, because you cannot take a powder that is available today and a machine that you can buy from somebody and make these parts. So over the last number of cycles, we've spent about $1 billion developing these processes. These machines are unique. The materials are unique.
The machines, as we buy them, we don't use them as is. We modify the machine to do what we want them to.
Right. So people are asking about the difference between forgings and orientation of crystals and things like that. If you just went and tried to do this without developing your own materials and your own processes, you cannot get the material properties.
Yes, sir.
Brian, I'm curious, what do you think are the biggest limitations to additive technology as you start integrating them into your business? What are you trying to solve for the most in terms of using this technology?
Well, first of all, we like weight, right? Cost. Now, there are some parts that you will probably never make with additive. I mean, if you have a little L bracket or something, you can stamp those out a lot faster, right? So you have to be smart about it. You're not going to do everything. But weight, cost, and performance. You know, Mohammed talked about that you have fewer parts, so instead of designing something with an assembly mindset, how do I assemble this? And every time you have an assembled part, you have an interface, you have two joints. And if it's in the airflow, those joints create a little turbulence, even though we work very, very hard to eliminate it or minimize it. So when you can now plan on smoother airflow so you can get performance up. But I would say initially right now, it's weight, probably weight, cost, and then performance.
Yeah,
in that order.
Here's what I answered from an engineer's point of view, and I apologize for those of you who. So, in engineering, we always do a trade. You know, we trade between cost, weight, and efficiency. Additive gives you all three at the same time. That's why for the first time I saw it, I couldn't go home. I remember that day, I said, oh my God, all of these 30 years of anxiety, do I want it heavier or do I want, it all can go away. And that's the breakthrough that we can see now. You can get all three. The only technology that can give us all three simultaneously is additive. Everything else you have to say, and we go back usually to the product manager and say, okay, hey, can I be a little heavier? I can give you more efficiency here. Can I be a little costlier? This one brings it all together. And that's the breakthrough that we've been waiting for. Yes.
Kind of
Yes.
following up on the same question, can you talk about when you'll be ready to print rotating parts and parts that are in a hot section? Because I think those are still the limitations that you face. When will you be ready for that, and how will you know, and how will you sure that those are
Yeah,
also
it's-
robust?
So it's a learning curve. I am playing with that now. If I tell you right now, my boss will hold me accountable and I gotta deliver on that day. I prefer not to commit to that date, but it won't be too far long.
So we're talking a few years with some sort, not that.
You're a great man, I'm not gonna answer that. That's it.
Yeah, so one more, and, oh, no, go ahead, please.
I just wanted to know how long it takes to produce this part.
So this one took me about less than a month, probably. So if I was doing all these 85 or 90 parts traditionally, it would have taken me, the cycle time total would have been probably somewhere 6 to 8 months. From the day we released it to the machine until we took it out of the machine was less than a month. Yeah. Yes, sir.
Robert, did you have a
Oh,
question?
yeah, I was gonna ask, you're obviously cutting costs because it's gonna be less man hours to produce it, and you're gonna be cutting costs because there are fewer parts to manufacture and all that. But in terms of reliability, and robustness, aren't you gonna increase the strength and the lifespan of these products because they don't have all these joints and all these?
Right, that's the whole thing, you know, when the gentleman asked me earlier, when traditionally you trade weight, cost, efficiency, time and wing. This thing brings all of it. So let's say you had a joint that was wearing. The joint is no longer there. You don't have to solve for the wear. Let's say you had 200 parts, now you made one. All that logistics of managing 200 different part number is gone. You don't need a warehouse to stock the 200 parts anymore. The multi-material that you needed, the welding, it's gone. You don't need a welder anymore. All of that goes away, and it's, you know, it's something that brings a lot of benefit in with a very sophisticated manufacturing. As I mentioned before, when we buy these machines, they are not able to naturally produce that, but our engineers play with the machine and make it to do that. Yes, sir.
If it takes a month to produce, how do you ramp up to produce large numbers of engines?
Several more machines.
Just keep adding machines?
Yes, so right now we got, I want to say probably 150 or so machines across. You know, I see a day that thousands of them sitting there and some engineers sitting someplace else sending this in, and they start printing, and when they're done, they call you, say, I'm ready, come get it.
Meantime, you
And
take off.
speed up the machine.
Need somebody to.
That's right.
We're also working.
That's true.
At the top engine level, where do things stand with where you're going to build it within Europe?
Oh, for ATP?
Where will the ATP be assembled?
Yeah.
Where's Paul?
Well, yeah.
So the final assembly test will be in Prague, Czech Republic. But we haven't determined when we're gonna do the added.
Oh, right, so the answer to the question was,
Could you
the
stand up?
final assembly of the advanced turboprop.
He's the program manager for the ATP.
Yeah, so the decision we've made to date is the final assembly and test will be in Prague. However, where we're gonna do additive, we haven't made that decision yet. But we do know Prague's the center of the global ATP headquarters.
You want to do it in Europe, the additive part as well?
We're open book right now. We're looking at the best place to put it based on everything you just heard.
We do, I mean, today we print parts in Camari, Avio. These are, you know, yes. Yes.
Given the extent and potential extent that you could apply additive to the ATP, do you expect to see actually performance benefits even beyond what you'd originally designed?
Yes, definitely do. You know, when I opened up with ACT7, it's a 40-year-old machine. When we put it together and we printed it, the efficiency got better, and the weight came out. And Brad is very familiar. That's when before we ran it, we said we got to go tell our boss. And then when we saw the results, it was music to our ears.
And the reason that we did this, the CT7, is that the architecture of the advanced turboprop is based on the CT7. compressor, et cetera. So the basic architecture, the start of the idea on how we were going to make the advanced turboprop, we went and we looked at our core expertise, CT7 and T700 cores, and that formed the basis for the start of the design of the ATP. So this was a great way to develop these processes for the advanced turboprop.
Yes, sir.
Can you talk about how the acquisitions of RCAM and Concept Laser figure into the production plans for these engines? Are those going to be for this kind of production, or are those for sort of next generation things that you're?
Both. So since, the reason we are acquiring those companies are because we're gonna develop this technology to serve third parties, GE, and all other different segments of the business, automotive, healthcare, whoever their customers are, that would be.
Are you concerned though about giving away then proprietary technology that you would have in those companies to other third parties?
Oh, there
Part of
would,
the sales
yeah.
of those
Yeah,
machines?
no, again, since those deals aren't completely closed yet, I'm not gonna comment on those. But, when we'll cross that bridge when we come to it.
Any other questions?
Any other questions?
How are we doing on time?
Yes, sir.
I have a very simple question. All your other engines have nomenclature CT7, CF34, we got ATP. Is this gonna be a nomenclature with an H80 ATP? And also your Passport, what nomenclature will you have for that?
Okay, so the Passport, that's the actual brand and trade name for the
Will it
engine.
have a number?
I don't even know what's on the data.
Passport 20.
Huh?
I think it says Passport 20 or something.
Yeah, Passport 20.
Yeah.
Passport 20.
Passport 20.
Okay.
Okay,
And-
so first of all, the ATP, I just want to clarify, there is, except their turboprops, there's no part commonality between the H series and the advanced turboprop.
Okay.
Okay, they are two completely different machines. Okay, we're calling it advanced turboprop. We don't have we're not ready to release the name and the model designation yet.
But you will have one.
Well, it will be called something. We're not quite ready yet. I have to save something for the next show, you know.
No, that's all right. All I have to do is know that that is forthcoming.
It's forthcoming.
All right.
Yeah, it's forthcoming. Yeah. Thanks, Marissa. Any other questions? I thought you guys would enjoy hearing Mohammed. Mohammed is off now developing the whole additive business for GE, not just the aviation products, the engines and stuff. So he offered to come down and share this with you. I hope you found it very interesting, as well as the services and the updates on the program. And then I guess that concludes what we're going to talk about, but we'll stick around and answer questions one-on-one. And we do have more of those cupcakes in the back for you to have on the way out. Or what you just stay.
Thank you so much.
Thank you.